Hello everyone, introduce myself. My name is Emiliah with name 21034009 with subject English for Physic with Supervisor Mame Fadhila Ulfa Jhora S.Pd M.Si from Physics Study Program at State University of Padang. Okay, I will present the result of the final project entitled Temperature and Heat Thermometer Scale. Temperature and Heat Thermometer Scale. Temperature is a measure of the heat energy stored in an object. High temperature objects have high heat energy, and vice versa. Heat is the transfer of heat energy from an object with a higher temperature to an object with a lower temperature. A thermometer is an instrument used to measure the temperature of an object. There are 4 common scales used for thermometer. Number 1, Celsius. Number 2, Reaumur. Number 3, Fahrenheit. Number 4, Kelvin. The Celsius and Fahrenheit scales are commonly used in measure temperature in everyday life, while the temperature scale defined as the international unit is the Kelvin scale. Calculation of heat in substance heat can result in change in temperature of the state of a substance. Acceptance of heat will increase the temperature and can change solids into liquids or liquids into gases. The results of heat will lower the temperature and can change liquid of solids or gases into liquids. The heat received or released by an object can be calculated by the following formula. Q equals M times T times delta T plus M times L, where Q is the amount of heat, M is the mass of the object, kilogram, T is the specific heat, J per kilogram, and is the change in temperature, OC, if the object undergoes a change of state. Then the amount energy used is calculated by the formula M equals L, where L is the specific heat of change of state of the substance. The unit of measurement for heat is the calorie, where 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 10 Celsius. 1 calorie is equivalent to 2 joules. Heat transfer. Heat transfer can be divided into 3 types based on the intermediate medium. The 3 types of heat transfer are conduction, convection, and radiation. Number 1, conduction. Conduction means that heat energy moves without being accompanied by a permanent movement of the medium that is the conductor of heat. Examples of conduction are heat propagation in metallic material such as iron, wire, and aluminum. At the molecular level, Conduction occurs due to collisions between higher velocity molecules and lower velocity molecules. This results in increase in molecular kinetic energy with further increase the temperature. Number 2, convection. Convection is the transfer of heat that occurs along with the transfer of an intermediate substance or medium. Examples of convection are cooling a room with air conditioning and heating water. At the molecular level, an increase in the temperature will have an effect on increasing the volume and density of the medium. The looser medium will move downwards and the denser medium will move up. A more tenuous medium is a medium with a lower temperature, whereas a denser medium means a higher temperature. This movement between the media causes heat transfer. Number 3, radiation. Radiation is the transfer of heat energy without the need for a conductor. Heat is transmitted by emission of electromagnetic waves. At the molecular level, heat radiation occurs due to the random movement of momentum and atoms due to electromagnetic radiation. Each object will emit thermal radiation depending on the heat it does. The hotter the object, the greater the radiation. One example of heat radiation is the transfer of thermal energy from the sun to the earth and other big objects. The three types of heat transfer can occur simultaneously in heating process. An example is the process of heating a pot of water on the stove as shown in the following figure. The heat propagation of fire from the stove to the pan is a radiation process. Then the hot water at the bottom of the pan will move upwards to exchange position with the water at the top, resulting in heat transfer through convection. And the heat contained in the metal pot holder can be transferred to the top, and through the process of conduction. Black principle. Black principle is a law which states that for all change of thermal energy or heat, the heat received by the lowest temperature material will be equal to the heat released by the higher temperature material. Mathematically, the Black principle is stated as follows: Q of Q S.Pd. If two materials with different temperature are mixed together, the Black principle can be used to determine the final temperature of the mixture. Mathematical application is as follows: Q of equals Q S.Pd. M1 times T1 open brackets T1 min Tm close brackets equals M2 times T2 times open brackets Tm times T1 close brackets. Information: μ1 equals mass of higher temperature material. C1 equals specific heat of higher temperature material. T1 equals the temperature of the material with a higher temperature. M2 mass of large temperature material. C2 equals specific heat of large temperature material. T2 equals the temperature of the large temperature material. Tm the final temperature of the mixture. That's all my presentation. Thank you for watching. I hope it's useful. See you all.